Guys, what we do is we hide, guys, please. What we do is we hide identities inside of the problems, which means a lot of times you have to simplify what you have to start with prior to doing any of the work. So in this case here, you've got tangent squared, sine, and secant. So that means you have to try to figure out some way to put everything in terms of one of the trig identities. Since you don't know anything else about any of the other identities except for the 6 trig functions, well, you know, your cosine, sine, tangent, and their reciprocal properties, but you do also now know one of the trigonometric trig functions. Yes. The Pythagorean identity of cosine squared plus sine squared is always going to equal 1 because that is just the Pythagorean theorem on the unit circle. So in this case, the dead giveaway is the fact that it's written in terms of tangent squared. You know nothing about tangent squared except for the fact that it's just tangent squared. So I had to sit there and think, okay, sine secant. Well, sine secant is the exact same thing as saying, well, tangent squared x, this sine times 1 over cosine.
Oh, you just have to flip it?
Yep. And then when you multiply fractions, you're multiplying straight across, right across, which means you get that. And what's sine over cosine? Tangent.
So then you just divide by tangent?
You can't. If you divide by tangent, you wind up with a, you don't wind up with a 0. You wind up with a 1.
Oh, so you have to take it over factor.
Correct.
Oh, and I did
Yep.
this other stuff.
So in this case here, you have to subtract out the tangent. Yes, ma'am?
Oh, what happened to the cosine of x?
What happened? Oh, I just forgot to write down x.
Oh.
That's all. You might not have heard me say this yesterday. I have a bad habit when we're moving a lot of trig functions around. Yes, they're all going to have a variable of x because you're looking about talking about some angle. I have a very bad habit of forgetting to write x a lot of times. Okay. And as we get into simplify verify after spring break, I'm never going to use the variable because it just gets to be messy. And I don't expect that you do either because it will get really messy. So here I can't just divide out, because if I divide out it equals 1. I need to set aside equal to 0, which means I subtract. And what's your first rule of factoring? Factor that out. So you're asking yourself 2 separate questions. You're asking yourself, what angle, do I need to write out tangent x equals 0, show how I move it around? Can I just say, what angle has a tangent of 0? Are we okay with me just saying that now, I hope? What angle has a tangent value of 0? And what angle has a tangent value of 1? Well, tangent being 0 means it had to be 0 in the numerator and 1 in the denominator. What trig, remember, tangent is opposite over adjacent, so it's y over x. That means that y has to be 0 and x has to be 1 when you're placing it upon the unit circle. Where is y 0 when x is 1? Right there at 0. So tangent of 0 occurs at 0. Now, doesn't it also occur here? Because what's 0 divided by negative 1? 0. It's yeah, the other one's 0. It's the negative 0, you know, the bad one. I'll come back to general stuff here in a second. Tangent equaling 1. In order for tangent to equal 1, that meant that the opposite and adjacent has to be the same value. That only occurs where? At the 45/45s. Tangent of 45 being positive occurs in the first quadrant and the third quadrant. So that gives you pi over 4 and a pi away, pi over 4. So now that would be in terms of if you had to list out all of them. What changes about what I asked yesterday was general solutions. When you're going from 0 to pi and pi to 0, from 0 to pi to 0, it has the same interval going both directions. All you're doing is adding pi between the two. So the general solution for this side would be 0 plus pi n. Whereas the other side, same deal. These two are pi away from one another, so the general solution would have been pi over 4 plus pi n. Yes, ma'am?
So when there's only one, like, value, then it'd be plus 2 pi n? Like, there,
No.
right there's 2 points. But when there's only 1 point, isn't it plus 2 pi n?
What happens if you have this? What happens if you have what if it's a sign value where you have 5 pi over 6?
I'm saying, what if it were just like pi over 6?
Then yes, it would be pi plus 2 pi n.
How do you know when there's like multiple?
When are things positive? When are things negative? All students take calculus. Think about your ordered pairs.
So is it only when it's negative?
Nope, you can't pigeonhole it. You have to be able to draw it and know what quadrants things are positive and what quadrants things are negative. Okay, so that's what you're looking at being able to do. So it's not there is no one size fits all, and we talked about this yesterday. There is no basic rule that if you see one answer, it's going to be plus 2 pi n. Because here, this could be an answer where two angles where things had occurred. There's 2 of them, and the difference between the 2 is different. So my general solution would have been pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi n. You could have 2 answers where one of them is, they could be pi away from one another. That's the same. It could happen. It just depends on each individual problem, or is its own independent solution. There is no blanket negative times negative is positive. See what I'm saying? There's no blanket rule for that. All right? Operate.
So, for the problem we just did, we know tangent is sine over cosine.
Mhm.
It's x over
Y over x.
y. So what if it were,
Wait, so
it's like sine y? It's sine y.
Y over r. That's where it goes back from the beginning on 10-2. We first did trig of angles. All right. What were you saying? What other one did you? Somebody.
Tan is just y over x, right?
Yeah.
Okay. Oh, the other problem was 41.
41 is the other sneaky one. Secant's the inverse of cosine, isn't it? Yes, ma'am.
With the last one, what happened to like the sine x and secant x?
They turn into a tangent. Yeah. Because remember, secant is, you go back to your trig identities, the identities that we know. We only know 6 things. Secant, just this part here, is 1 over cosine. Cosine is 1 over secant. That was one of the trig identities we talked about back in 13. 2.
Like, we never, like, I don't think we were putting, like, that's right.
All right. So if you go into the next one,
Yeah.
secant is the inverse of cosine. It's the reciprocal property. So you rewrite it in terms of cosine. So secant is 1 over cosine. Now, if I subtract that over, I get it equal to 0, but it's not going to really help me with anything. So in this case, this is the time that I'm going to multiply it by cosine. Because 1 over cosine times cosine equals what? 1. So if I multiply both sides by cosine, I get 2 cosine squared equals 1. And now what do you do with the coefficient? Divide by 2. And then you take a square root. When you take a square root over an equal sign, what do you have to put in there?
Plus or minus.
Plus or minus, very good. So we're going to have what value of what angle has a cosine value of plus or minus 1 over root 2. Now, I don't rationalize these types of problems to figure out the rest of it, because it's just a waste of time. There's no reason to do that. Because cosine, remember, is your adjacent over hypotenuse. And right away with that root 2, you know what triangle you're dealing with. You deal with the 45. Now, I'm looking at a cosine value that's going to give me a 45-degree angle. It's plus minus, so it's going to be all 4 quadrants at pi over 4. So when I'm all 4 quadrants at pi over 4, remember it was pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Each one of these is 90 degrees apart from one another. Because if you go back and look how when we built our unit circle, we knew we had 4 right angles, and the distance between each root 2 over 2 to the negative root 2 over 2 to the positive root 2 over 2 and back and around, all those lengths are all the same, so it creates a square. So each one of these, it's just, well actually it's just pi over 4 plus pi over 2. Because this is 90 degrees, 90 degrees, 90 degrees, 90 degrees. If I start at 45 and I add 90 degrees, I'm at 135. I'm at 90, I get 225. I add 90, I'm at 315. I add 90, I'm back at 45.
Wait, so pi over 2 is just another 9.
The only time that this is, all right, for those of you that like basic statements that want to fall back on something that works all the time, this is a good one to remember. If you have all 4 quadrants of pi over 4, general solution is always pi over 2. Because it's just, they're all 90 degrees apart. When you get pi over 6s and pi over 3s, they're not the same distances apart because they create rectangles. This is how it works.
How wrong would you be then if you said pi over 4 plus pi and then 3 pi over 4 plus pi?
Wrong, because you can make it more basic, or you can write it more basic. Because this is the, when you have pi over 4s in all 4 quadrants, it's the only time that your distance is always is less than a pi. It's always 90 degrees. It's always pi over 2. It's the only time that occurs.
So it's not wrong, but it's not right.
Correct. It's wrong-ish. It's wrong light.
Yeah.
It's crystal wrong.
No, wrong 0 now.
All right. What else you got on there?
Wait, I don't.
Combine like terms.
Yeah, 37.
Wait, you weren't supposed to divide it by cosine of x, right?
Nope.
Yeah, that's what.
Can't do that.
That's what I keep wanting to do. I
That's
didn't do
what
it
I
on
keep-
this one, but every time I see it, I'm like, just divide it and you can get rid of them all.
And this comes back to the idea when we were doing polynomials, when you guys would try to, when you guys would have stuff where it was,
Yeah, 'cause I never do that where I get rid of 0. I always fit it the other way.
you guys would just say, oh, divided by x, you get 8x squared. And you would try to factor it that way instead of realizing that you have 3 zeros as opposed to 2. You're eliminating a possible 0 when you do stuff like that. You can't do that. It's bad. Very sad moments. Treat this like you would combine like terms. Subtract the 7 over. Okay, so subtract the 7 over, and we're going to get cosine, cosecant squared minus 4 cosine x equals 0. Excuse me. Now, those two terms have something in common. What do they have in common?
Cosine.
Cosine. So now I can factor out a cosine. And I have 2 terms in which I can set equal to 0. Yes, ma'am? So I have cosine of x is 0, and then cosecant squared of x minus 4 is 0. So the first one's pretty quick. What angle has a cosine value of 0? Well, cosine is your x value. So if your x value is 0, that means you're at, exactly, you're at pi over 2, 3 pi over 2.
Like, how do you know that there's 2? Why wouldn't it just be 5?
the reason I'm listing them both out to start out with LeBlanc is because when I list them both out, then I go back and realize, okay, is there a specific difference that's the same between those two? To go from pi over 2 to 3 pi over 2 is pi. To go back from 3 pi over 2 to pi over 2 is another pi. So I can go between the two the same amount each time. That's the only reason why I'm listing them both out to start with, but my general solution would just be pi over 2 plus pi n. And the reason why I'm looking at this here, it's on a quadrantal. Because those are my ordered pairs. Okay?
Oh, yeah.
Cosecant squared x minus 4 is 0, which means I'm going to get what angle has, well, cosecant squared of x is 4. So what angle has a cosecant of plus or minus 2? Plus or minus 2 being the cosecant. Cosecant is the inverse of what trig function? Sine. So if you go back and think about it, sine being an opposite over adjacent, that would have been a 1/2.
Opposite over hypotenuse.
I'm sorry, thank you. Opposite over hypotenuse would be 1/2, and I say, and that gives you the 30 degree.
Yeah.
So that means the inverse would also be the 30 degree, because then it'd just be 2 over 1. 30 degree cosecant being positive occurs, well, where sine is positive, first and second. So you're at pi over 6, 5 pi over 6. Now, those two are not the same distance apart as you go completely around the circle. So the general solution for these guys would be slap a pi n next to both of them. Thank you. Yes, LeBlanc, you're right. I'm sorry. I meant 2 pi n. Here I'm getting so hung up on the idea of like, oh, we didn't go all the way around. You're.
Confused for a second, I'm just like, wait, what? So when it be all four quadrants?
Yeah, really long.
Oh, it was. Yeah. Good morning. Sorry. Oh, sorry.
I was really confused for a second.
Because it was plus and minus. I forgot it was plus minus.
Yeah.
Wait, why is it still pi n even though it's not minus?
When you go from pi over 6 to 7 pi over 6,
Oh, I thought it was from pi over 6 to 5.
I forgot that I forgot that I was plus minus. I saw the plus and I wrote down plus 2. That was my fault. I forgot that it was plus minus.
So can we just like take a calculator?
Yeah. I didn't hear you. All the pies that I made? Yeah, I have a lot of pies. Oh, hey, speaking of pie down. I came up with rules real quick. 1 second, I'm working. I'll get right to you. All right, what do you want? You're at bated breath. What do you got?
I was just gonna ask about one of the other ones.
I'll get it. 1 second. What I've decided to do with that whole sliding scale thing is 20 digits of pi will get you 2 points.
So
Every-
it's only 20?
Come on, just let me finish the whole thing. Jeez.
No, I was excited. My school's one.
For every 15 points after that, it's an additional point.
That's awesome.
The winner of this classroom gets a 5 bonus point.
It is a competition?
Yes.
Yes.
That's why it's a pi down.
Wait, repeat Yeah.
Wait, can we write it down? We actually understand.
One of those three is
Somebody already knows what's wrong.
I'm going to have you write it down. I'm just going to give you guys like a half sheet of paper, let you write it down to be easier. That way you're not going, wait, he just said 3.1415. Wait, what did he say? You know, now we'll just write it down. We'll take 10 minutes to do whatever, and we'll finish up with whatever stuff I feel like doing.
And then take a nap.
Sure. All right. That's
down and like make it like
I'll get 20.
pretty much. All right. So what'll happen is if the winner of the classroom, if let's say, what did you say you have? 70. So if she wins with 70, she'll get her
I have
2,
I have 3 and many things.
3 for 35, 50, 65. So she'll have 5 points plus 5. She should get 10 points. And yeah, but I throw the quiz thing. So, oh God, no. I could not do this at all if you want.
no.
So the idea is whether it's a 3 points or anywhere between like 3 to 10 points, if you throw that into a quiz category, technically what that really works out to be, it's like 1.5 to 2 homeworks. 3 homeworks is really all it is. It doesn't seem like a ton, but with the way that it's weighted through, 3 to 5 points here or there is better than nothing.
Yeah.
If you would mean if you ended 20.
20 points extra credit.
Oh, jeez, I might have to cap it at a certain rate, but I don't know.
No.
If you show up and you know 1,000 of them, I'll give you the point. No, I'm not. Never mind. I don't want to say that, all right? Hopkins, save me, please. 37 mirrors the exact same thing we did in class yesterday. What happens when you have a squared term and a non-squared term, you always try to rewrite the squared term in terms of the non-squared term. What I mean by that is that you need to use the Pythagorean identity of this. If you know the Pythagorean theorem is x squared plus y squared is your radius squared, then you know that it's cosine squared plus sine squared, adjacent, opposite, and your radius is always 1.
I squared the whole thing and then factored.
That's bad. That's blah.
I don't even know why it took like half the page.
Well, if you looked at your notes, we did this problem yesterday as a sine squared and a cosine in the middle. It's the same thing. So that means that I can say that cosine squared is 1 minus sine squared. And I just fill it in from there.
No, it's
In the problem, sine is squared.
I know.
Take the Pythagorean theorem.
Using the Pythagorean theorem. So then I have 2 times the quantity, 1 minus sine squared, minus sine of x, minus 1 is 0. Distribute.
Oh wait, no, I did wait.
From there, you wind up with a negative first term. Factoring with negative first term sucks. Don't do it. Add everything to the other side of the equation. Yeah, well, it's just might as well just move it. It's just as quick. If I rewrite it, I just get 2 sine squared plus a sine of x minus 1 is 0. What times what is negative 2? You add together to get positive 1. Numbers, very good.
Negative 1.
Wait, I did.
Give a negative 1.
Wait, is it okay if we put it in terms of you?
Yeah, it's fine.
Okay.
Shouldn't it be a positive one? Oh, you put the 2. Oh, yeah.
There's a, if you guys remember from factoring way back when it was, August or September or whatever, the habit that I always get into when I have different signed SIGN terms as far as factoring goes, if one's positive, one's negative, I always write the negative one first. That way I don't screw something up out of the second thing when I do my GCF. That's all. So I always put the negative first. So your GCF then, as you group them, we have a sine of x. We have a 2 sine plus a 1. And it gives you terms. And you go from there. Okay? All right, let's add to this. I think there's two on here I want to show you real quick before we let you pull away.
Do we have homework tonight?
Yes. I haven't got there yet. I'm busy. I've got things. I'm an important person.
There wasn't like anything in this.
I know usually I'm pretty good about getting things updated, but sometimes I get slacker and try to figure everything else out.
Failed as soon as she went she came back. Some of the girls failed really fast. You're standing up in the car, and she moved something, and she didn't think the fact that the cabinet was open, and she snapped it closed, and I was like, wow. I was like, can I get like, can I have more shorter? Can't avoid cap practice. And don't reverse. It's revolutionary. Practice A or practice B?
The answer is yes.
Okay.
So on the A side, you cannot do 1, 6, and 13. You don't know enough about trig to be able to solve 1, 6, or 13. They all deal with trig identities. I'm not going to bother with those for you guys on those setups yet. On the other side, you should be able to get 1 through 12. Also, do not worry about where it says use your graphing calculator to approximate the solution, things like that. We're not worried about using calculators. We're not worried about graphing any of these things yet whatsoever. What I want to make sure we understand is how do we set up and solve the equation stuff. What I want you guys to be able to do is try and get through as much of this as you can. Some of them say general solution, some of them say within one revolution. We'll go over more of this tomorrow, then I'm also going to recap a whole bunch of the review junk that I have for you for the quiz. The quiz will be all non-calculator. 13.2, 13.3, 13.4, and 14.4. And that's all on Thursday. Yes, sir?
Does it say not to do 1, 6, and 13?
Yeah, on the A side, because you can't. Because you don't know what a double angle is, and I'm not going to worry about setting you guys up with the, the identities for secant squared or the other ones. But I do have one that I want to walk through. Yes, ma'am?
So are we not doing 13?
No, that's just those here. Is it this one? Yes. I want to look at number, is it 9? Yes. Look at number 9 on the B side real quick. I want to walk you through this one. I want to walk you through how to do this one. You don't need to worry about any trig identity, or sorry, you don't have to worry about any of that Pythagorean identity because nothing is squared, so you don't have to worry about that. But what I want to look at is, I need to set one side equal to 0, so I need to make a decision. Do I go from right to left or left to right? I want to move left to right, yeah. Because if I want to pick on the little guy, I'd move the 2 cosecant, and then I'd have to move the other one, so that way I can deal with positive terms. So I'm going to move everything from the left to the right. And I'm going to get 0 is cosecant x plus root 2 cosine x cosecant x.
And then you just factor out the cosecant.
Correct. And then I just put 0 on the other side because I like it on the right. I don't know. So yeah, now you're at the point then right away you can factor out the cosecant. So we have cosecant x is 0. And then the next one, oh, let me do this, sorry. Show what I'm doing first. Sometimes. We have those two terms, which means I have one of them at cosecant of x equals 0. And then the other one would be cosine of x is going to equal negative 1 over root 2. Everybody okay with that? Subtract 1 divided by root 2?
Sure.
So this is what angle has the cosine of negative 1 over root 2. So this is asking me what angle has a cosecant of, what angle has a cosecant of 0? Cosecant is the inverse of what trig function? Sine. So there's two ways I can go about doing this. This is the same thing as saying, if I inverse this side, I'd have to inverse that side. So it'd be sine of x equals, what's the inverse of 0? Undefined. Is sine ever undefined? Think about your unit circle. Think about the unit circle. When you're on the unit circle, sine starts at, it's 1 and 0. It goes to 0, 1, negative 1, 0, and then 0, negative 1, and back to 1. So if you think about what sine does through the quadrantals, pi over 2, pi, 2 pi, and so on. At 0, sine starts at 0. At pi over 2, it moves to 1. At pi, it goes back to 0. At 3 pi over 2, it goes to negative 1, and it goes back to 0. So at, So if you look at it graphically, the value of sine is never undefined. It's a constant function. There's no asymptotes to it. So when you think about it in terms of cosecant, cosecant would be taking all of these points and inverting everything, right? What's the inverse of 1? It's 1, not the opposite reciprocal. The inverse of 1, just flip the fraction, is 1. What's the inverse of a half? 2. Inverse of a half? 2. What's the inverse of 0? What's the inverse of negative 1/2? Negative 2, 1, negative 2, back to here. And obviously you have the next one up here. So a cosecant graph, which we'll get to, is an inverted sine graph. Will cosecant ever equal 0? No, you're right. Because sine equals 0, which means cosecant can't, because they're inverse relationships to each other. So that what value of x equals 0 for this is a big old-fashioned no. You can't do it. Yes, right. Or undefined, whatever. You can't. It's inconceivable. Yes, ma'am. All right, so that's why that works. It does not work like that. Hi, what's up?
Hey, Love Power.
I think I left a bunch of note cards in here.
You did.
Because that looks like my giant binder clip that I would have.
They're underneath my note things of stuff. No, that's on the shelf. Hey, look, we just did a cosecant graph.
What? You're graphing cosecant? You're a jerk.
Well, why does it? I'm saying why is?
Oh, look at him.
Why can't we find the cosecant? What angle has a cosecant?
Is this
of 0?
honors algebra 2?
Yeah.
You know, when you're not in the honors section, you get note cards that look like this. Everybody should take my section of algebra 2. Woo! You probably have your sister. I do have your sister. Bye, everybody. Enjoy your honors experience. It is a lot of fun.
You know what's crazy? He was a senior in high school when I started working here.
That's weird.
I know, isn't it?
You just dated yourself.
My dad has been yeah.
I didn't know him though, because I didn't have it. I have the smart kids.
He's pretty cool though.
Well, no, I didn't need it like that. I just had
Sure.
repeat or pre-algebra.
You did?
Yeah.
Like the seniors taking pre-algebra.
Good. Anyway, so the next one is what angle has a cosine of negative 1 over root 2? It's going to be a 45. Cosine is negative in which two quadrants? 2 and 3. So you're going to be at these two angles for your cosine being negative. Reference angle of 45 degrees puts you second quadrant at? Well, 3 pi over 4, and then the third quadrant would be 5 pi over 4. Yeah, these, I don't know if 9 said general solution. Yeah, this one said on the interval, so this one would just be list the two answers.
Wait, so if it doesn't say general solution, adjust
Right.
the result.
When it says within, if it's within one revolution, write down every answer that you can get. If it's general solution, you try to make it with the plus pi n's or 2 pi n's or pi over 2 n's, whatever it might wind up being.
Wait, so what do we do for 1 through 6, 1 through 5?
So for this one, it's just the same answer.
Have the same style. Doesn't stay style. Freestyle, do whatever.
It's free, yeah, it's freestyle. Did it get cut off?
Yeah.
Yeah.
I think those were general solutions.
Yeah, it says it's general. Well, it doesn't ask for the general, so you just give up like what it
Yeah, the next section is general solution.
Hey, trust me, you need to practice. All right, work through those. We'll take some time tomorrow. I'll go over some last minute ones, see how we do. Okay?
It's like when they did the.
I gotta post that. I totally forgot about that.
They wanted the acronyms.
This is the same as the last one.